So we got this magnetic dipole here, and there's a moment going through it, and we're looking at the angle of this magnetic field, and there's this little equation that's going to give us the potential energy depending on where that magnetic field is pointing. And we know that this little thing is going to be released at this particular rotational kinetic energy, and we're going to try to find the max angle that it'll get to. So, in order to do this, let's realize it was released at the 0 degree mark, which means right here. So, the initial mechanical energy, like that's the total mechanical energy, is going to equal to the K naught plus the U naught. So that's going to be initial kinetic energy, 7 e to the negative 4 joules, plus the initial potential energy, which if it's at 0 degrees, we know that at 0 degrees our potential is a negative 4.75. So we'll actually subtract 4.75 e to the negative 4. And these are in joules. So that's going to be our total mechanical energy throughout this entire thing. You know, we can't, conservation, right? So minus 4.75, this is the negative 4. All right, so the total energy in the entire system is going to be 2.25 to the negative 4 there. Now, we want to know what the max angle is. So we're going to ask ourselves, okay, if we get to the maximum angle, like imagine a pendulum, right? Pendulum like this. You're gonna think, okay, when is this thing gonna turn around? The maximum potential is going to be right here. So maximum U. And this is going to be 0U, but maximum kinetic energy. So this is KE max, or this is U max. So once we get up to here, this is the maximum possible angle, and we know that the KE is at 0. So it stops there for a moment. So that's the key. When this thing reaches the maximum angle, KE equals 0. So going back to our equation of mechanical energy, we'll just put 0 for the KE, and then we'll this has to be the rest of it, because 2.25 is the total. And so we know that that's essentially just what we can just kind of say that the U is equal to 2.25 e to the negative 4. So now we can try to calculate this angle, figure out where we are, because now we know U. We need to refer to the equation for potential energy, which is going to be like this: the negative magnetic moment dotted with the magnetic field. This yields the equation negative mb cosine theta. And we can actually try to figure out what MB is, because we're going to need that for figuring out what the answer is here. Essentially, we're going to set this equal to 2.25 negative 4, and we're going to divide this in order to get cosine on this side, take the arc cosine, and figure this out. But we need to know what MB is before we can do that. So in order to figure out MB, let's use this formula that we have over here, and let's plug it into some of these values. Like, for example, let's just go where, so it's kind of like negative MB cosine of theta. So if cosine was 0, then we know that this is supposed to be 1. And that would be where that is. So if this goes away and that becomes 0 degrees, and this is over here, we know that the potential energy is supposed to be negative 4.75 e to the negative 4. So we actually figured out what MB is. Get get rid of those negatives and figure out what MB is. So now we can put that in there, and we'll get that. So let's see what we got. 2.25, and then there's a -4. And we'll get the negative MB version. So it's actually the negative of whatever we found over here. So it's 4.75, -4. And it's confusing with all these negative signs, but we're doing this right. So we got this, and we're going to take the arc cosine. There. So we got angle is 118.3 is the maximum. Crazy.